Welcome friends. Here we'll discuss some funny results of mathematics, and from this we'll try to create interest in mathematics. How this mathematics is interested and what happens when we are making some mistake in our steps when we are solving some problems. And if we are making some mistake in meanwhile step, then this becomes funny in that problem and that creates funny results in our problem. Now here firstly we'll go towards our Indian mathematician, that is Kaprekar, and we'll find some Kaprekar numbers. Before that we will try to understand what is the Kaprekar number. If we are considering any 2 or higher digit numbers, and condition is that all digits should not be equal. If we are arranging these numbers in descending order and subtracting ascending order of this number, and if we are continuing the same process, then we will get one constant number. That constant number is called Kaprekar. So we are very proud to use Kaprekar number because Kaprekar is Indian mathematician. Here you can take any example for 2 digit, 3 digit and so on digit numbers. Surely we are getting one fixed number when we are doing this type of operation, that is arranging this number in descending order and subtracting ascending order. I will give some few examples here. These are the 09, 495, 6174, 63954. These are the some Kaprekar numbers of 2 digit, 3 digit, 4 digit, 5 digit. In 5 digit we are getting another one also this number, Kaprekar number, and here all these are the Kaprekar. How to find out this Kaprekar number? We try to understand by taking one example and find here Kaprekar. We'll take one example. Randomly we'll take any 3 digit number. I'm taking 435 is our 3 digit number, and our aim is to find out Kaprekar number for 3 digit number. For that we have to write this number in descending order and we have to subtract ascending order of counts. Our descending order is 543 and ascending order is 345. If we are subtracting, we get 198. Now again from this number, descending order is 981 minus ascending order is 189. Then we are getting now this number 792. Again we have to rearrange this number and we have to write descending order minus ascending order. Then I will continue this process. We are getting this descending order and ascending order. Now again from the 693 number we will try to write in descending order minus ascending. We are getting 594. This 594 number we will again write descending order and ascending order. We will get this number 493. Now again we are getting this 493. That means this 493 is a now fixed number or 3 digit number, and this fixed number we are getting by subtracting descending order and ascending order, and this is the 493 is our fixed number, and this fixed number is called Kaprekar. You can take any 3 digit number, try to follow this process, and then you will get this fixed number. This fixed number is called Kaprekar. This is for 3 digit. You can find similar way 4 digit, 5 digit, and so on. Now practice it and try to find out new numbers for 4 digit, 5 digit, 6 digit Kaprekar numbers. Now this is about interested number. Now here we will consider another funny result. In this result we'll use here some simple algebra, and here in this algebra I will suppose x is less than y. That means here this is any number less than this number. That means here we will suppose that this is 4 is less than 5, 6 is less than 7, in that way. This is rational number. Now I will multiply x squared on both sides. Then we will get this x squared is less than or equal to x1. Then I will subtract y squared from this equation, inequality, subtracting y squared on both sides. Now here this is x squared minus y squared and this is xy. Now here from this right hand side we can take y common, and from left hand side we will write here factors x minus y, x plus y. Now here is x minus y and x minus y. We will cancel this x minus y and x minus y. Cancelling x minus y on both sides, then we will get here x plus y is less than or equal to 1. Now this is interesting. That means here if I put x is equal to 4 and y is equal to 5, this is surely nothing but x is less than y, and we are getting this final result 4 plus 5 is less than 5. Now this is a tested one. We are not doing anything, we are following all these steps algebraically correct, but we are getting wrong result. Wrong result in this is 9 less than 5. How this is? Guess it. Why we are getting wrong result? Even though if we are following all these steps correctly, but also we arrive at this contradiction, we arrive at this wrong result. Why? Think on this. Here this is highlighted term. This highlighted term having something problem. Some problem is there, and because of that we are getting here wrong result. This means we are doing wrong calculation, and due to that we are getting 9 is less than 5. This wrong result. Okay, now this is replaced one. Oh, we will try to check 0 is equal to 1. Suppose we will consider, means here to solve this result you should know integration part. If I will consider integration of dx divided by x, but I will try to solve this integration by parts by keeping second function as 1. Means I will write this integration as here 1 divided by x into 1 into dx, and I will suppose this is your first function and this is your second function. I will use here by parts, integrating by parts. Now we are knowing the rule of integrating by parts, and using this integrating by parts, this we have to keep 1 by x as it is. Integration of this second function is x into integration derivative of this function 1 by x is minus 1 by x squared. Integration of this function is x. Now here this x and this x squared is get cancelled, and we write here this minus sign minus 1 plus. This is dx divided by x integration, and here integration of dx divided by x. This dx divided by x integration and this dx divided by x integration can get cancelled, and here we are getting 0 is equal to 1. Oh, again here this is impossible result we are getting. Again this result we are getting because of we are doing something wrong calculation, and because of that we are getting this wrong result. Yes, think on this. Now I am highlighting here, and because of this we are getting wrong result. 0 is equal to pi. We have to prove this. We write here cos theta is equal to cos theta plus 2 pi. This is periodic function with period 2 pi. And again, I will give one example of this. We are knowing that our festivals are there, and in this festival we are doing Dasara and Diwali. Dasara and Diwali, distance between Dasara and Diwali is 15 days, but distance between Diwali and Dasara is not a 15 days. Are you getting? The same logic here we are applying. This is cos theta. Cos theta is equal to cos theta plus 2 pi. This is our periodic function with period 2 pi. And we are supposing that this is 1 function, and due to that we will compare their angles. theta is equal to theta plus 2 pi, theta get cancelled, we are getting 2 pi equal to 0. That means 2 is constant, pi is also constant. How do we say that this 2 pi equal to 0? This is impossible result. We count this. Again, we will try to write the new result and we will try to check. We are knowing this famous formula given by Euler, e raised to power I theta equal to cos theta plus I into sin theta. I replace this theta by 2 pi and then we will write here e raised to power I 2 pi is equal to cos 2 pi plus I into sin. Now cos 2 pi is 1 and sin 2 pi is 0, therefore we are getting this is 1 and this 1 is nothing but I will write e raised to power 0. Again, this e raised to power 2 pi and this e raised to power 0. Exponential function is there. This is 1 1 function, that's why we will compare their angles. I 2 pi is equal to 0. I 2 pi equal to 0, this I is constant, 2 is constant, I is equal to under root of minus 1, this is constant, 2 is constant, and we write here pi is equal to 0. Yes. Something is wrong, but we are doing same calculation, we are not doing anything. We are following same steps, but we are arriving at the wrong result. Why this? Think of why we are getting this wrong result. Something is wrong in this calculation. But if we are observing this calculation, nothing is wrong. Oh, something is good. We are happening something and we are changing this mathematics and we are getting 0 is equal to pi or I 2 pi is equal to 0. How this is possible? Try to solve this, try to resolve, try to check where is wrong. E is equal to 1. Oh, again this is impossible to do. E equal to 1 negative. E is equal to, we will write e raised to power 1. Now e raised to power 1, we can write here same term divided by same term is equal to 1. 2 pi I divided by 2 pi and this 1 by 2 pi divided by 2 pi. Again e raised to power 2 pi I into bracket I will write here 1 divided by 2 pi I. We can write here, we can rearrange this is 2 pi I, 2 pi I get cancelled. But e raised to power 2 pi I will use here Euler's theorem, e raised to power I theta. And we are knowing that e raised to power 2 pi, this is cos 2 pi plus I into sin 2 pi, cos 2 pi is 1, therefore this is 1 raised to power 1 upon 2 pi I. Now blindly we are saying that, now again here purposely I am saying blindly we are saying that 1 raised to power anything is equal to 1 and we are getting this is equal to 1 and here we are getting wrong result, e is equal to 1 and we are knowing that 1 raised to power something is 1 and we are getting the wrong result. Why? Where is wrong? Which step is not correct? Now we will try to prove 1 is equal to minus 1. But this is not true. We are getting wrong result. Here we will write here 1 divided by minus 1 is equal to minus 1 divided by 1. If we are taking square root on both sides, this is under root of 1 divided by minus 1 equal to under root of minus 1 divided by 1. We are not doing anything wrong here. We are only taking square root on both sides. Here we will write separately squares, numerator and denominator. Square root of 1, square root of minus 1 is equal to square root of minus 1. And we are knowing that the square root of 1 is 1 divided by square root of minus 1 is I. We are saying root of minus 1 is I. If we are taking cross multiplication, then we are getting I square is equal to 1. But I square is equal to minus 1. And we are getting again wrong result. Which calculation or which step is wrong here? Yes, in mathematics we are getting some interesting result. Again we are getting this wrong result because we are doing something wrong in some calculation, in some steps. Now again we are knowing how to find area of triangle. By here, suppose I will take this triangle ABC and whose dimensions are there 1, 2, 3 respectively. Two sides having their dimension, and we have to find area of this triangle. The dimensions are given, length of the sides are given, therefore we will use here Heron's formula, and we are knowing this is Heron's formula. Area of triangle is equal to under root of s into s minus a into s minus b into s minus c, where s is equal to a plus b plus c divided by 2. ABC, we will suppose this is 1, 2, 3 are ABC. From this formula S, we will find here yes, ABC will put here 1 plus 2 plus 3, we are getting this is 6 divided by 2, and from this, if we are putting 6 divided by 2 into 3, and here we are getting 3 minus 3, and we are getting this area 0. Even though dimension is here, but we are getting area 0. So how is this possible? This could not possible. But again, we are knowing this logic of this triangle. We will not form this triangle. This is not a triangle actually. 1, 2, 3 sides are there. That means this is not a triangle. Therefore, we will not find here angle. So we will not find here like area of this triangle. Because here we are making some mistakes, and because that we are getting this answer as 0. Now here we will write 1 square is equal to 1, we are making. But 2 square you can write 2 plus 2. 3 square you can write 3 plus 3 plus 3. 4 square you can write 4 plus 4 plus 4 times. In general way, you can write x square as x plus x times. Now, if we are differentiating this with respect to x, then what will happen? Derivative of x square is 2x, and derivative of this x is 1, this x is 1, this x is 1. How many times? X times. 1 plus 1 plus 1 x times. We are getting x. Therefore, we are getting 2x is equal to x, and we are getting wrong result. Oh, 2 is equal to 1. Actually, this is not possible, but we are getting wrong result. Tell me, this step is wrong. Now here we have proved 2 is equal to 1. This is impossible result. This is contradiction. Now we'll prove log 2 is equal to 0. Actually log 1 is equal to 0. But here we have to prove log 2 is equal to 0. Now we are knowing this Taylor's expansion. Log of 1 plus x is equal to, this is Taylor's expansion. X divided by 1 minus x squared divided by 2 plus x cubed divided by 2 and so on. Now we'll put x is equal to 1, then we'll get log 2. Log 2. Now these terms containing plus and minus terms. I will collect plus term in one bracket and minus term in another bracket. Here 1 by 1 plus 1 by 3 plus 1 by 5 in this term containing odd terms, and minus, this is minus 1 by 3 minus 1 by 4 minus 1 by 6 minus comma, and this even terms are there. Now I will arrange here. I am keeping this term as it is, but I am adding this bracket and subtracting same bracket. From this, what is happening? See, from this I will take subtraction of these two brackets, means we are getting 2 into this whole bracket, and I will insert this 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 and plus 1 by 6, all these even and odd terms. And here this minus bracket 2 times. Therefore we are getting this equation as 2 into this term. I will multiply 2, and then we are getting this first bracket, and if we are multiplying this, getting this 1, this 2, this 3, denominator. And here first bracket minus second bracket, both brackets are same. Therefore this is equal to 0. Oh, why we are getting this is equal to 0? Something is wrong. We have to check this. This step is not possible. Now we will discuss this funny proof. If we are taking notebook, and on notebook we should write here 1 divided by infinity is equal to 0, and we are knowing that 1 divided by infinity is equal to 0. This is infinity is extended here. We are knowing this 1 divided by 0 is equal to infinity. 1 divided by 0 is equal to infinity. We'll rotate. If you are writing this 1 divided by 0 on your notebook, you should write here 1 divided by 0 on your notebook on plain paper, and then rotate this to 90 degree in anti-clockwise direction. In this direction. Rotate your notebook in anti-clockwise direction to this. Then you will get clearly idea. Rotate this in 90 degree. Then you will get this picture. This something like 8 is equal to sign in this way, and is here minus 10, just like your notebook shows in this way. Now here you should write minus sign, then you should write 8 and keeping equal to sign, and here this is 8 minus 8 is 0, and keeping this sign as it is here, this is minus 10 minus 8 is minus 8. You should write down on your page, then you will get this clearly, and you are getting this picture 0, this sign, minus 18, just like 0 sign, and this is minus 18. Now here we have to rotate this notebook or page in 90 degree in clockwise direction. Then we'll get this picture as 1 by just like infinity is equal to 0. Now we are getting this is the study proof of this 1 by infinity equal to 0. Okay, we are enjoying here some funny results of mathematics, and here we are getting this result because of our wrong calculation, and due to this wrong calculation we are getting some wrong result, impossible result. Okay, even though if we are doing wrong calculation, but still we are enjoying this. Okay, thank you. For answers of this, you should share me your answers, or which type is wrong. Otherwise, you should give message to me. I will help you to find our wrong steps or why we are getting this wrong.